20, this is 1.1, number 11. And this one gave a little bit of trouble to some of you students. A bit of a tricky question, I guess I would say. The terms are expressions here, right? They're not numbers, they're expressions with an x in there, okay? But all of the rules of arithmetic sequences and arithmetic series, all of those rules, I guess we haven't done series yet, all the rules still hold true. So it says determine the value of x, given that this is an arithmetic sequence, and these are consecutive terms. Okay, so I gave you a little hint yesterday. I asked you to find out what the common difference was. So if you take any two terms and find out what the common difference is, you would do this. You would do 7x minus 4 as one term, and you would subtract 5x plus 2. Okay? So you would take one term and subtract the term that's just before it, right? And so this is equal to the common difference. Now remember to use these brackets because you have to subtract the entire expression. I saw in some of your work yesterday, some of you did not use the brackets, you're going to get the wrong answer. You have to subtract the entire expression. And that means this negative sign distributes, really. So this is 7x minus 5x is 2x. Negative 4 minus 2 is negative 6. Okay? Does that make sense? So this is the common difference. Okay. So how does that common difference work? Well, what you could do is you could say, I know how to use the common difference in an arithmetic sequence. And that is, I could take one term and add the common difference to get the next term. Right? You could do that. And so you could take any one of these terms, the first to the second, and you could add the common difference to equal the next term. So let's take these two as an example. And so what I'm going to do, I'll change pens here a little bit. I'm going to go 7x minus 4, and I'm going to add my common difference. That's 2x minus 6. And that should give me the value of this next term, 10x plus 6. Okay? So that's one way you could think of it, right? In an arithmetic sequence, you take one term, you add the common difference to get the next term. And when you get the next term, it's equal to the next term. So here I've set up an equation that has one unknown in it, just x. And so this x is going to be the exact same value in all of the expressions, right? Because that's how this works. So here you have an equation and you have x. So let's try and solve for x and see what we get. So 7x plus 2x over here is going to be 9x. Negative 4 plus a negative 6 is minus 10. And we've got 10x here plus 6. So in order to solve for x, we get all the terms over to the terms together. So I'm going to subtract 9x from this side and from this side. That's going to give us 1x over here. I'm also going to take 6 away from both sides to move the constants to the left. And that's negative 16. Okay, now that's what I get. Did anyone that got this question also get negative 16? Yeah, awesome. Okay, good. Now, you may have done this a slightly different way. Did anyone do this a different way? Slightly different way, maybe? Yeah, a little bit of a different way? Okay. Is it easy to explain what the difference is between what you did and what I did? Okay, that's actually a very valid second method. So here's what you did. So you took the difference between the first two terms and you got this, right? Then you took the difference between the second two terms and you'll get a different expression. What was your expression that you got there? 3x plus 10, okay? So that also equals the difference. So here's what Chloe did. She basically said, I know the difference is this expression and the difference is also this expression. So if you want to do it that way, you could totally do that. And you could, because they're both equal to d, both these expressions are equal to d, that means that they're also equal to each other. So here's another equation you could make. 2x minus 6 equals 3x plus 10. They are both expressions for the same difference. We have an equation, we have one unknown, we solve for it. Subtract 2x, you get x here, minus 10, x equals negative 16. Another way to get x, okay? So again, that's a different perspective there, okay? Good job. All right, so that's number 11.